So previous class we discussed about the introduction of the force and how the motion is caused by the force. What is the definition of the force we learned. So in this chapter, in this class, we will discuss about the Galileo's approach to understand motion. So what Galileo thought and what was the thinking of Aristotle. Aristotle was a Greek philosopher. Now what he thought about the about force and what was the Galileo's thinking regarding this force. That's what we learn today. The first thing is that what Aristotle believed. So he believed that the force is required to keep an object in motion. It is written here, you can see. Otherwise, it would come to rest in the absence of force. So what he said that if the object is in motion, then you have to keep on give the force. So that is the thing. And what Galileo said, Galileo opposed what Aristotle has observed. Galileo said that the body is in motion, will continue to move with uniform speed in a straight line provided no external force acts on it. So they are completely different things. So he said that you need a force to keep on move the object, so that the object if I don't apply the force, the object will come to rest. And what Galileo said that a body is in motion, will continue to move with uniform speed in a straight line provided no external force is applied. So that means if we don't apply the force, otherwise the object which is motion, so always keep on move. So it is also said by Newton also. So this one, now there is one small explanation of this. So I'll try to explain this one. So now think about the two inclined planes are here, two inclined planes like this. Even you can do in your home with some bowels or all, take it and you can do it. So take a ball. This is one inclined P. This is P. This is Q. This one is R. This is S. So normally you take this type of curve here. Now we'll take a ball here. So this is the initial position of the ball. Initial position. Now if I release the ball from here, the ball will go in this way and it will reach the same height. It will reach the same height here. This is the final position. Okay. So this is my inclined path. Now if I change the inclination of the path, so if I do like this, then I can, if I make the inclination of the path like this, in this way, if I release the ball from here, so again we'll observe that the ball will reach the same height here. So again the ball will reach the same height in this point, particular position. Now how do I do? If I change some little bit different thing, that if I make the inclination in this way, but there is no inclination at all. So what will happen? Normally what we learned from the previous observation, the ball was reaching the same height. It released from here and this side, the ball will reach the same height. Here also, if I release the ball from this side, the ball will reach the same height here. But here, see, there is no height at all. So what will happen? The ball will keep on moving. The ball will keep on going. Understand? But normally what we observed this, that the ball will get stopped after going to some distance. Why? Because the frictional force is working in the opposite direction. Okay. So that is why the ball gets stopped. Otherwise, what will happen? If the friction force is not there, the ball will keep on moving. So it was said by Galileo, and he did this experiment also to prove this one. So if you understand this one, so if there are equal inclinations, what will happen? The marble will roll down from one side and attain the same height on the other side. The equal inclination is there, and when the inclination is decreased, then the marble will roll down and move to the inclined plane and attain the same height on the other plane, but cover the longer distance. Here is covering the longer distance. This is the distance. So if I take this one as S1, this one, and this is S2. It's covering the longer distance. So S2 is obviously greater than S1. Now, in this case, when the inclination is reduced to 0, so there is no inclination here, so marble will roll down from the inclined plane and continue to move in the horizontal plane as long it may be. Okay, because what if this ball need to reach the height, so they will keep on going. Okay, so that's the Galileo wanted to say. Now, according to Galileo, so there is some definitions, some laws of inertia. It came. Okay. So what I said, that the object will come to rest because of the friction. If this path is completely polished or there is no friction, the object will keep on moving. So I'll explain the concept inertia afterwards. But you just, because as I started these things, so I have to tell this one because it was said by Galileo only. This is written in quotation also. So what is this? So when no unbalanced force is exerted on a body, it stays at rest or moves in a straight line with constant speed. That is, it will remain unaccelerated. So I'll explain this one. I'll explain you these things afterwards. So just to understand this one. So in this way, the concept of force and motion has been arised. Now we learn about two different branches of study. Normally we do in the physics. So first one is kinematics and one is dynamics. So what are the difference things between the kinematics and dynamics is that the branch of physics which deals with the study of motion without the taking care of the cause is called the kinematics. Okay. So what is kinematics? The deals with and opposite dynamics is the branch of physics which deals with the study of motion, being the taking care of the cause is called the dynamics. So as we write here, the branch of physics taking care of so this will be taking care of the cause, and this is without taking care of the cause. So remember these two things. This is kinematics. Last chapter, the motion chapter, we are discussing with the motions without taking care of the cause. So now in this chapter, we'll discuss about the motions with the taking care of the cause. That is called the dynamics, and the previous chapter was the kinematics. So these things now, small things I want to tell you is already you know this one as it is there in the continuation. So I have to tell. So what are the effects of the forces? So effect of force. Effects of force. Normally what the force can do? The force can cause motion. First one is force can cause motion. So example will be a football when kicked, then it will go forward to the goal post. Okay, railway engines runs the compartments attached to it. So there are the example. Now the force can stop motion. So next one is force can stop. So example, a moving ball can be stopped by force of your hand. Okay, so a rotating top can be stopped by your hand, or a moving ball stopped due to the force of friction offered by the floor. So there are the example. And next one is the force can change the direction of motion. So what is this? So when the batsman hits the ball with its bat, the direction of the ball will change. The cyclist turns handles of the bicycle to take a turn. Okay, this is the example. And force can change the speed of the moving body. Fourth one, force can change the moving body. So what are the examples? Um, suppose if you want to increase the speed of my cycle, so what you have to paddle with more force, so to apply more force so that the speed of the cycle can be increased. And several more examples are there. And next one is the force can change the shape and the size of the object. The force can change the shape and size. Okay. So now if we take a spring or rubber band, if we pull the spring, the spring will get expanded. Okay, so or the length of the spring will increase, or if you apply the force on the opposite direction, the spring will get compressed. Or if you take a balloon and if you apply the force on the balloon, so the balloon will get compressed. So that the things are there. So that is why the force can change the shape of the object. If we hammer any object to give the shape, suppose if I take an piece of iron, if I make it red hot and then we hammer this one, then we can give it different type of shapes of that particular iron. So that is why the force can change the shape and the size of the object. So in this class we learned about the Aristotle's thinkings, then the Galileo's thinking about the force and what is kinematics and dynamics, and also the effects of force. So we learned 5 effects of force in the chapter. So now next class we'll discuss about the balanced force and unbalanced force. So thank you very much.